Hello, here's part 2 of the adding subtracting fractions. Just to kind of shorten the videos up, I decided to split them into two. So in the previous one, I talked about adding fractions and how we have the big questions of can I, why, and how can I. So we still apply those same questions to our subtraction problems because we cannot add or subtract unless our denominators are the same. So I'll set up a problem here. If I had 7/10 minus 1/3 equals blank. Okay, so can I? No. Why? Because my denominators are not the same. So there's my can I and my why. So okay, how can I? Well, 10 and 3 will land on 30 together. Then they're multiplied by themselves, each other. So I'm going to go 10 times 3 is 30. And remember, whatever I do to the bottom, I do to the top. So if I rewrite my problem, I'm going to get 21 over 30 minus, so now 3 times 10 is going to give me my other 30. And whatever I do to the bottom, I do to the top. 1 times 10 is 10. And now I'm set up with a problem that, yes, now I can solve this. And remember, denominators don't change and we don't add or subtract them with each other. So right away, I'm going to go put over 30. And I have a very basic subtraction problem now. 21 minus 10 is 11. So 11/30 is going to be my answer for the problem of 7/10 minus 1/3. So moving on from just regular fractions, I think that's pretty explanatory again. Just make sure our denominators are the same. I'm going to move into subtracting of mixed numbers, which is a little level up of just regular fractions because they start to throw in the idea and the concept of borrowing. So when we borrow from a fraction or a mixed number, it looks a little bit different. So I'm going to set up a mixed number here. Remember, a mixed number is a whole number with a fraction. And I'm going to subtract it by, I'll just do a regular fraction to start off. I won't do a mixed number. So we'll do 4 3/10 minus, we got to do something higher than 3/10 value. I'll do 4/8. All right. So we take a look at this problem here now, and we still do the why, can I, why, and how can I. So before I even start making any moves here, I got to look at my denominators. And again, I notice that my denominators are not the same, so I need to make them the same. So a little trick with this here is when we look at 4/8, everyone has been getting on the clue here to remember that that's half. So in some situations, you may have to do, when we're doing with 10s and 8ths, you may think of, okay, well, 40. 10 lands on 40, 8 lands on 40. That's their first common multiple. Or remember, there's the trick that some people will just do your denominator times the other one to make a common one, which is 80. Now, when we go that high, there's going to be a lot of reducing that has to take place. So when we have something like half, it actually makes it a little bit easier. So because I'm thinking of it as half, there's actually not a need to change my 3/10, because all I will do is think to myself, well, what's half of 10? Well, 5. So I could actually rewrite 4/8 as 5/10, and that's an equivalent fraction. And now they're both out of 10, so my can I question now turns to a yes. So now I'm going to rewrite my new problem here just to have it cleaned up a little bit. 4 3/10 minus 5/10. And just like in any regular subtraction problem, if we were to set up a problem like 30 minus 18, and everyone's first step, we look in our ones, well, I can't take away 8 from 0 if I don't have any. And well, we learned when we were younger to borrow from the 3, which is in the tens place, to give that a 2. And then since we're dealing with base 10 numbers, we always add 10 because I'm in the tens place value. Well, we can apply that same borrowing knowledge into fraction subtraction. So when I look at my 3 minus 5, I can't do that. So what I'm going to do is I'm going to go to my whole number 4, and I'm going to borrow from the 4 and make it a 3. And now in mixed number subtraction, where you're going to do the carryover, like I did the 10 in that little subtraction example on the right side, is I'm going to add whatever my denominator is, I'm going to add that to my numerator. So in this case, it is going to be adding 10. But if I had something like 4 3/6, I would be adding 6. If I had 2 5/9, I would be adding 9. You add whatever the denominator is to that numerator. So in this case here, again, it's 10, so I'm going to change that from a 3 to a 13. So now I have 3 and 13 tenths, which in a way is actually equivalent and the same of 4 and 3 tenths. It does not change the value to borrow. Okay, so when we think about, how that relates to regular subtraction over on this side here, in this number here, I would have 2 tens, which is worth 20, and 10 ones, so 20 plus 10 is 30, so there's my original number. So when we borrow, we're not changing the value of the number, we're just rearranging the value to help ourselves out. All right? So it's just like saying, okay, I have 2 $5 bills is the same as 2 $10 or 1 $10 bill. There's no value change there. Or if I go to the bank and trade out, a $100 bill for 5 20s, it's still the same value. So that's the mindset you want to have, is that 3 and 13 tenths is the same as 4 and 3 tenths. So now I can subtract. So I'm going to do 13 minus 5, which is 8. And remember, our denominators don't change in this situation, so it stays at 10. And since I don't have any whole number with my second fraction of 5 tenths, I'm just going to bring that 3 and think 3 minus 0 is 3. So 4 and 3 tenths minus, in the beginning here I had 4 eighths, minus 4 eighths is 3 and 8 tenths. So there's where the little borrowing action can happen there. And that's kind of the most complicated thing that we would see in the mixed number and fraction subtraction. All right, I'll do another example of a mixed number, and I'll do another one that involves borrowing here. So 5 and 2/6 minus 2 and I'll do 10/12. Okay, so I'll pick something a little bit easier here to help our converting to be a little bit quicker. So again, can I? No. Why? Because my 6 and my 12 are not the same. So how can I get them to be the same? Times these both by 2 and rewrite my fraction. So I can erase that here. So 2 times 2 is going to give me 4. And 6 times 2 is going to give me 12. So now can I? Yes. Why? Because my denominators are now the same. Now taking our second look at this, I look to subtract my numerators. I cannot take away 10 from 4. I don't have enough. So I borrow. I'm going to borrow from this whole number of a 5 and make it a 4. Now I'm going to change that 4 here. What I'm going to do is add the 12 below it. So 4 plus 12 is 16. Now I'm ready to roll. I have 4 and 16/12. Remember, that doesn't change the value. 4 and 16/12 is the same as 5 and 4/12. So I can now subtract 16 minus 10 is 6. Our denominator does not change. And now I can do 4 minus 2 is 2. And if I were to look at this to quick reduce that, I know, oh yeah, 6/12 is half. So 2 and 1/2 would be my final answer. So 5 and 4/12 minus 2 and 10/12 equals 2 and 1/2. If you have any more questions on these, feel free to reach out and ask. And again, it's always easy to just make up your own examples for the subtraction. Just pick some numbers. I'll add one quick thing onto the end of this one since I forgot to add it onto the addition video. I'll show a quick adding mixed numbers problem for us here today. So same concept is going to take place with having to have our denominators be the same. But I'll do something, let's see here. Let's do this one here. All right, so 5 and 3/8 plus 6 and 2/6. So can I? No. Why? Because my denominators are not the same. How can I? This is kind of like a little a call and repeat that the students do in class that they're getting really good at. So what can I do with my 8 and my 6? Well, they both land on 24. So that can really help me out to make it a little simpler than instead of saying 6 times 8 and make them 48. So times this by 3, times this by 3. And what I'm going to get is 5 and 9/24 plus, well, this would be times 4 and this would be times 4. So then I'm going to get 6 and 8/24. So now can I? Yes. Why? Because my denominators are the same. So now I can go ahead and add. I like to start with my numerators. 9 plus 8, 17. 24, stays the same. I do not add those. Again, a big common mistake we've been having is students are adding these together, and that will make an answer wrong. All right, and then I finish up by doing 5 plus 6, which is 11, and there is my final answer for that one. The only way that addition can take a little turn for a little difficulty is when we'd be left with an improper fraction. So let me set one more problem up here and we'll call this video done. Just set up a problem here that will lead us to an improper fraction. I'll try to keep it a little bit quicker. And we'll do like this. So we'll do 4/6. All right, so can I? No. Why? My denominators are not the same. How can I? Well, 10 and 6 both land on 30. So I'm going to go 10 times 3 and 8 times 3. And underneath that, I'm going to rewrite this as 2 and 24 over 30 plus, so 6 times 5 and 4 times 5, because remember, whatever I do to the bottom, I do to my top. So 3 and 20/30ths. So now can I? Yes, because my denominators are the same. So 24 plus 20 is going to give me 44. Denominators don't change, and 2 plus 3 is 5. So now I'm left with an improper mixed number because my numerator is bigger than my denominator. So remember that strategy here of how to make impropers a mixed number. I'm going to take a 30 out of 44, and because I can do that one time, that means I'm going to add 1 to my 5. So that 5 is going to become a 6 in my new answer. When I take that 30 out of 44, I'm going to have 14 left over, and my denominator does not change. So I'm left with 6 and 14/30ths, and I can cut those both by 2. So 14 divided by 2 would be 7, and 30 divided by 2 is 15. So my best final answer would be 6 and 7/15. So we've talked a little bit in class about all these possible answer choices. So when we look at something on if it were a fill-in-the-blank test or a student had to give a short answer, we've talked about how, in a way, this is an acceptable answer. You probably just wouldn't get the full points possible. 6 and 14/30ths is an acceptable answer. You might get more points than the 5 and 44/30ths answer, but not the full points. What would get you the full points is the full reduced version of 6 and 7/15. So hopefully this video can help you out. And again, if you ever have any questions, dojo message, comment on the video, or just feel free to ask in class.